So today we will now I will just give you an understanding of what is the random effects model. Now this may not be I may not ask this for your exam, but for your other tests that you are studying, I think this will be helpful to you. So you have studied the fixed effects models of panel data that will be asked definitely for your exams. And what is the problem there? So you will be having what different cases, I cases and t times. So there will be lots of regressors. So too many regressors, numerically unattractive. So that's a problem of multicollinearity. And then in this case, we are unable to identify the impact of time invariant variables. For example, sex, color, ethnicity, education, etc., which are invariant over time. And for a given pause, it's also possible that for a given period, the error term for the General Motors that we have studied as example is correlated with the error term for another case. So there are too many regressors, there's a chance of multicollinearity, autocorrelation, etc. And that is the limitation of fixed effects model. And now we just will have just an understanding of random effects models. Random effect model is also known as error components model. Okay. So random effects is a regression with a random constant term. See, yit is equal to beta 1 I plus beta 2 x2 it plus beta 3 x3 it plus uit. So instead of treating beta 1 I as fixed, we assume that it is a random variable with mean value of beta 1, and the intercept value of an individual company can be expressed as beta 1 I is equal to beta 1 plus epsilon I. So it's called a random effects model because the whole what changes in the panel data is captured by the intercept term. Here we take the intercept term itself as what variable. Normally the intercept term is fixed. So here in the random effect model, we take the intercept term as variable. That's why I have written yit is equal to beta 1 I other than beta 1. So beta 1 is the average. You had the example of 4 companies where the intercept for average of the intercept of the 4 companies is given as beta 1, and for the individual companies, for example General Motors, you will write beta 1 plus epsilon 1. Epsilon 1 is the difference from the mean value for what General Motors. If it is Westinghouse, you will write beta 1 plus epsilon 2. That is why I have written that the intercept value of an individual company can be expressed as beta 1 I is equal to beta 1 plus epsilon I, where I is equal to 1, 2, 3 and n. Okay, and epsilon I is a random term with a mean value 0 and variance sigma squared epsilon. So substituting 2 in 1, that is the epsilon this thing that is ui. 2 means beta 1 I. Instead of beta 1 I can write beta 1 plus epsilon I. So it can be written as yit is equal to beta 1 plus beta 2 x2 it plus beta 3 x3 it plus epsilon I plus uit. Okay, epsilon I was that which went together with the intercept term, and then uit is what? The error term. Okay, then yit is equal to beta 1 plus beta 2 x2 it plus beta 3 x3 it plus wit. That wit is equal to epsilon I plus uit. Now, how do you estimate the random effect approach? It's also known as error component model. So here, random effects is a regression with a random constant term. Constant term itself becomes what? Random. So yit is equal to beta 1 I plus beta 2 x2 it plus beta 3 x3 it plus uit. Instead of being beta 1 as fixed, we assume that it is random, and the intercept value can be expressed as beta 1 I is equal to beta 1 plus epsilon I. So I am repeating the whole thing, and then you substitute this, where epsilon I is the cross section or the individual specific error term. Okay, that was beta 1 plus epsilon I. So that is the cross specific or the section specific or individual specific error term. And uit is the normal error term, which will have the impact of combined time series and cross section error term. And the term error components model derives from its name because The composite error term WIT consists of two error components. Hmm? WIT has two components. What are they? Epsilon I, which is the cross section or the individual specific error component, and UIT, which has both the time series and the cross section component. The usual assumption made by error component model is expected value of epsilon I UI equals 0, expected value of epsilon I epsilon j is equal to 0, expected value of UIT UIS is equal to expected value of UIT UIJT. Now that's 0. That is, the individual error components are not correlated with each other and are not autocorrelated across both time series and cross-section data. The intercept represents the mean value of all cross-sectional intercepts, and the error component represents the random deviation of individual intercepts from its mean. So the composite intercept term WIT is equal to epsilon I plus UIT. Expected value of WIT is equal to 0. Variance of WIT is equal to sigma squared U plus sigma squared epsilon. That is the the term is serially correlated. Now variance becomes this too. So OLS estimates become biased and inefficient. Hence we use the GLS estimate. So now that you can skip. So which model is better? So please have an understanding of this because it may be asked for one word questions. If T is large and N is small, there is likely to be little difference in the values of the parameters estimated by FEM and ECM. T is large means what? The time component is large, and N, the number of cases is small. FEM and ECM will give you the same result. So the choice is based on your convenience. FEM may be preferable. But when N is large and T is small, see N is large, you have 30 cases and T is only 2. The estimates obtained by the two models can differ significantly. So FEM is used when the individual units are not random drawings from a larger sample. ECM is used if cross-sectional units are considered as random drawings. So if you from a large population you are selecting some random units, then error component model is better. If N is large and T is small, and if the assumptions underlying ECM hold, ECM estimates are more efficient than FEM. So if N is large, you have 30 cases and only 2 time points, then it is always better to have ECM estimates. Okay, so from this portion I won't ask for exam, but when you are going for your UGC or other exams, please have an understanding to write the objective part of this.